For all those who appreciate the work that we're doing here on Standing for Truth, please hit that subscribe button because we are just getting started.
All right, looks like we are live for an exciting one tonight, guys. I promise you. Thank you for the patience. Good to see a lot of people in the chat. We got a good mix of our evolutionist friends and our creationist friends. So this is going to be a lot of fun. Mitchell, thank you so much for the super sticker. We've already got super stickers and super chats coming in. Thank you so much, guys. Mitchell, Doki Doki Bible Club. And yeah, guys, this one is going to be exciting. We've already got 50 people in the chat. David, I think you bring the numbers, or maybe it's Neff. Maybe Neff being moderator brings the numbers too. So thank you both for being here. Nephilim Free for moderating, David Neff for doing this debate, and both of you gentlemen are on mute. So before you speak, just make sure you unmute yourself. And
yep. Well, thank you very much, Standing for Truth, for doing this debate. This is kind of a last-minute thing. I know you emailed me late last night saying, hey, you want to do a debate last night? And you emailed me just as I was about to go to bed. But I said, I will do it today. And so here we are. So I'm David Neff. I'm a musician, and I do a lot of debates, open mics, stuff like that. I am getting ready to transfer into university, probably the University of Colorado, where I will be hopefully getting my undergrad in molecular, cellular, and developmental biology. So that is a little bit about me. Standing for Truth, I'll turn it over to you.
Awesome. Thank you. Yeah. I told you, David, I said, David, get a coffee, pull an all-nighter, let's have a debate. But I think it worked out the best that we do it tonight. You're no stranger to this channel. I mean, we've debated, who knows, 20 times. You've debated Neff. You've debated Kent several times, so you're no stranger to debates, nor this topic. So this is going to be a lot of fun. We're debating Neanderthals, evolution or devolution. I'm going to hand it over to Neff, who is the moderator for tonight. He's going to go over the format as well as just kind of let you guys know to tag him with questions. Neff, thanks for being here.
No, it's my pleasure. So the debate is Neanderthals, evolution or devolution. In one corner, we have the famous Standing for Truth. In the other corner, we have the famous David P. Neff. And we're going to go at it. And there's going to be 10-minute openings, then about 50 minutes of open discussion. Then we'll have a Q&A after that. And so David Neff is going first. Is that correct?
Yes, I am going first.
And
a real quick announcement. There are 2 after shows. One is going to be on John Maddox's channel, Logical, Plausible, Probable. And there's also going to be an open mic show on my channel as well. Okay. So lots of stuff to look forward to.
Yeah. Okay, I thought about starting one myself.
Okay. Well, in that case, guys, yeah, exactly. We're going to keep it opening statements, a nice discussion of about 50 minutes to an hour, as many questions as we can get to, and then we'll have, it's Friday night. So Friday night, open mic night. Looks like there's going to be a few after shows that we can all get to when this is done over with. So
okay then. So David is going first. 10-minute openings each. David, when you're ready, I'll start my timer.
Okay. Can you pull up my PowerPoint? My world famous PowerPoints.
That's the least I can do for you, David.
Okay. When you start talking, I'll start the timer.
All right. Well, thank you so much, Standing for Truth, for agreeing to debate me on this. And thank you so much for Nephilim Free for moderating. I do appreciate both of you guys. So let's take a quick look at Standing for Truth's model. Standing for Truth claims that Neanderthals are fully Homo sapiens, that they are highly inbred, that they were rapidly mutating, and that they diverged after the flood, either shortly before or shortly after the Tower of Babel. Let's review the timeline, and I'm going to show why this timeline is an impossibility. So creation happened in 4004 BCE. The flood happened in 2348 BCE. The Tower of Babel, the flood 2348, the Tower of Babel 2242, and the first Egyptian pyramids supposedly 250 years later, and then the Abraham around 1996 BCE. So for this to be even remotely plausible, there needs to be sufficient amount of time amount of people to build the ark. Who's making the tools, the material, the flock, the food, the clothing, and all of this after a global flood supposedly wiping everything out. And then I mentioned all of this was supposed to happen during a global ice age. So let's look at some of the population mechanics issues with just populating the world. So at Babel, this is from Answers in Genesis. Babel Answers in Genesis estimates that just 400 people would be alive at the time of Babel, and this is 50 times the original starting population of 8, and only in about 100 years. Another article, Answers in Genesis, tries to double the population every 150 years in order to get to the present day population. If this was the case, then there would have been less than 16 people at the time of Babel. So what the problem here, of course, AIG starts with the conclusion, then extrapolates backwards to find the answer. And yet, in even another article, Answers in Genesis doubles the population every 15 years in order to get enough people to build the pyramids. So, but of course, if this number was accurate, then there will be far more people alive than there are today. And his debate with Walker, Standing for Truth, admitted that there would be only 1,000 to 2,000 people alive at the time of Babel. So let's get into the waiting time problem. There needs to be sufficient time for the population to rebound, and the time needed for the populations to migrate, the time needed from Neanderthals and all the other human species to appear, and the time needed to build the cities, and all the extant biodiversity needs to be here in less than 500 years after the flood. Now, let's talk about hypermutating. Hypothesis: Neanderthals were highly inbred and hypermutating. This leads to testable predictions. Genetic data should show evidence of hypermutations, and it should also show that populations that are highly inbred should mutate faster. And we have other populations today that are highly inbred. Of course, none of these predictions have come true. Inbred populations do not hypermutate. It is literally impossible. Neanderthals had low genetic diversity, and hypermutating populations would actually show more genetic diversity. So that is a direct contradiction to Standing for Truth's claim. Next, let's look at de-evolution. De-evolution simply does not exist. It simply cannot happen. De-evolution literally means reverting back to your ancestral state. So basically, de-evolution would be humans going back to a unicellular organism. Degrading genomes, genetic entropy, air catastrophe, etc., all of that is not de-evolution. So let's look at what the evidence actually shows. The evidence shows that humans and Neanderthals diverged about 550,000 years ago, that Neanderthals lived between 400,000 and 40,000 years ago, that they were morphologically distinct, and that they were genetically distinct from humans. Their Y DNA is genetically distinct. There is no evidence of Neanderthal mtDNA lineage in humans, no evidence of human DNA in Neanderthals, and phylogenetics reveals that Neanderthals nest outside the human clade. Standing for Truth might recognize this image from his debate with Walker. This definitively shows slam dunk 100% that the humans and Neanderthals are distinct sister species. And the p-value, which is derived here, is 4 by 10 to the minus 236. So basically that means that the chances of this here being wrong is about the chance of randomly picking an atom for the universe 6 times. Here are some questions that Standing for Truth must answer. When does he think that Neanderthals first appeared, and when did they go extinct? How did the population rebound so quickly post-flood? Why are there no trees that nest Neanderthals within the African clade, like he claims? How do you explain patriarchal drive when increased mutational load is a primary factor of male infertility? And finally, let's just talk about more problems with the whole Babel story. So in Genesis 11, Earth had one language, all migrated to the east and settled in Shinar, built a tower to the heavens to make a name for themselves. And God responds by confusing their language because, quote, this is only the beginning of what they will do. Nothing that they propose to do will be impossible for them. We have built 4 more towers and sent it all the way to the moon and Mars. So the language barrier can easily be overridden. So the whole story of the Tower of Babel just flies in the face of reality. and I think this is quite a pathetic deity. To summarize, the Tower of Babel and the Flood are impossible. Humans and Neanderthals are distinct species of humans. Humans and Neanderthals diverged about 550,000 years ago. Not enough time to get all the excellent biodiversity in less than 500 years. And with that, I am going to yield the mic.
Okay, so thank you, David.
How did I do in time?
You're actually 2.5 minutes short, so we'll give. I mean, that's just your loss.
You can give them to me if you want.
So, all right, it's Standing for Truth's turn to have an opening statement whenever you start. We'll give him up to 10 minutes since you gave up your time. I don't know what else to do with it. 10 minutes when you begin, Standing for Truth.
All righty, real quick, before you start my timer, let me just share screen here. Thank you for the opening, David. I think I can answer every single one of your questions. I won't be able to in this 10 minutes, so I'll give a brief opening, and when we go into the discussion portion, we can address those questions. So you can start my timer now, and let's get into it. So debate, Neanderthals, descendants of Adam and Eve, evolution versus devolution. Let me know you guys can see the screen, and we will go from here. Okay, so modern scientific data tells us in every way that Neanderthals are fully human. Back 100 years ago, they asserted Neanderthals were some half ape, half man, brutish type creature. And now we know they were highly intelligent and sophisticated, not predicted by the evolutionary community. Look at the change since 1856 and 2015. It's astounding. They were highly inventive and had a diverse diet. One thing very important to note is they ate tuna fish, which was actually an open water fish. Neanderthals literally had boats. Purposeful navigation is what this is, guys. What animal other than humans make boats and navigate the open seas? This requires high levels of intelligence. They even got to some of the islands in the Mediterranean that were never connected to the mainland. We know they buried their dead. They had music. They were into cosmetics. I mean, the list goes on and on and on. And I've had previous debates on this subject. So for more detail on that, check out those debates. So the evidence suggests, guys, that they were human beings made in the image of God. And worst of all for the evolutionists, though, we have their genes. The evolutionists I debate on this specific topic typically want to just wave away all this data, implying that this is not and has not been a problem for their evolutionary fairy tale. But as I pointed out in previous debates and received no rebuttal, the evolutionists did not predict this about the Neanderthals. That's the important point to consider. Okay, they just have to accept the data now. Except that once again, evolutionists did not predict the data that we have. This has all been rather surprising, when in fact it is biblical creationists that have predicted Neanderthals as being fully human, made in the image of God. And who said biblical creationists don't make testable predictions? Neanderthals painted in caves, made musical instruments, had the capabilities to control fire. They performed ceremonial burials. They even pointed the head toward the rising sun. They hunted the landscape for odd materials where they would grind them up and use them for makeup and cosmetics. Neanderthals also have the same FOXP2 gene that gives modern humans the ability to speak. They discovered that some Neanderthals carried similar versions of skin pigment genes that cause light skin and red hair, then green eyes and freckles when they occur in people of European descent. Now, I want to point out the obvious. The fact that the genetic evidence tells us that Neanderthals interbred with the direct ancestors of modern people. If we look to the biological species concept, then we are by definition the same species, just as predicted. It appears that people outside of Africa carry 3 to 4% Neanderthal DNA. Everything about Neanderthals, including their genetics, tells us they were in every way fully human and descended ultimately from Adam and Eve. Now, I want for a moment to look at the bigger picture here, okay? This comes to the bigger question behind the topic of the debate. Are we looking at evolution or devolution? This ultimately comes down to genetic degeneration, okay? Are we evolving or are we devolving? Does David believe humans are getting better genetically? I want to point out something very important to why our genome is degrading much more rapidly than we've ever imagined. The genome is both polyfunctional and polyconstrained. We know that the genome has multiple overlapping codes and overlapping messages. What's actually happening on the molecular level is science fiction. Okay, try to picture a chapter in a book and hidden or embedded within that chapter. Okay, in addition to the obvious meanings in the chapter are other meanings, additional meanings. Even in the same sentences, there may be several other messages embedded. We write books, but we do not write books that can be read both forwards and backwards. DNA can actually do this. This is data compression, guys, on the most sophisticated level. Let's talk about genetic degeneration. Now, in terms of genetics, what we have, okay, we have a genome of 3 billion letters. We know that the mutation rate is extremely high. It's approximately 100 new mutations per person per generation. And it also turns out we have 3 new mutations every cell division in our body. This is astounding. Mutations are essentially alterations in the DNA sequence. Harmful mutations vastly outweigh truly beneficial mutations, which means that harmful deleterious mutations are accumulating in the genomes of living organisms, including humans. And with beneficial mutations being incredibly rare, and most mutations being mostly deleterious, this means that the large-scale fish-to-fisherman type evolution that David wants to believe in so badly cannot be true. As far as Neanderthals go, they were a branch of early man. They were different. We have lost a lot of genes, and we have devolved a lot since the immediate post-flood world. Is it any surprise to David why Neanderthals are different than us today as modern humans? Okay. We are all more and more mutant every day. We are adding 3 new mutations per cell per day. All these mutations are coming in and they're having tiny effects. The next time somebody tells you that you don't look like yourself today, tell them, of course not. This is the most mutant that I've ever been. Now, here's the thing. If you change 1 letter in a genome of 3 billion, you are not going to have a huge effect. The effect, as a matter of fact, will be very small. It will be very subtle. But you've still lost a little bit of information. And if you don't stop this process, you are eventually going to destroy all the information. The majority of mutations are effectively neutral. The typical mutation has too small of an effect on fitness to actually be measurable. And natural selection cannot see these mutations. They are virtually unselectable and invisible to selection. Now, selection can, of course, act on the worst, most damaging mutations, okay? We have some mutations where you can see an effect, of course. 1 letter change can oftentimes lead to disease. But the typical mutation is not detectable in any way. Remember, selection acts on phenotype and not genotype. Selection happens for the whole individual. We are 100 trillion cells, and in every single cell contains 6 billion nucleotides. And so Mother Nature is going to have to decide if my body or David's body or Neff's body is going to be selected or not, to the extent of whether or not selection would work at all. Selection chooses the whole genome. And at the organism level, there is either reproduction or non-reproduction. This is pretty basic. What type of mechanism can David present us with here today that can filter out so many new mutations that are pouring into our genomes? Okay, have a look at the slide here. There's something called patriarchal drive that is going to be very important to this debate and this topic. What happens when very old people have children? What are the effects of biblical patriarchs having children at very old ages in the post-flood population that would have been very small? As David correctly pointed out, this would have been a small population. We accumulate more and more mutations throughout our lifetimes, meaning the older the father is, the more mutations he will pass on, theoretically. Neff, how much more time do I have, brother?
You have 1 minute and 30 seconds.
Perfect, thank you. Now, this is a problem, though, okay, guys? This is a problem for phylogenetic trees. When we look at family trees of people around the globe, okay, here's a family tree here on the Y chromosome. When you look at these family trees, these trees have a certain amount of mutations, which we can actually count. Now, overall, whether you look at a human Y chromosome tree or a mitochondrial DNA tree, we see very few mutations overall, showing us that we all descend from a recent Y chromosome ancestor and a recent mitochondrial DNA ancestor. The pattern is exactly what we would expect as a biblical creationist. How does David deal with this? But when it comes to the branches, this is important, okay? When it comes to the branches, it's important to note that the evolutionists assume that this is all based on the length of time that they've occurred. But if patriarchal drive is true, and very old people were having children, the length of these branches is not dependent on the amount of time. It's actually dependent upon the age of the parents. I also want to point out that when you root these trees on the evolutionary assumption, you don't necessarily have the same number of mutations along the resulting branches, which once again breaks the assumption of a molecular clock, the basis of where they actually place their root. Anyways, guys, there are numerous reasons why Neanderthals are different than us today as modern Homo sapiens, and I look forward to discussing these reasons with David. And patriarchal drive is going to be an important factor in this. And I've got a lot of things written down that David talked about, but I think what I'll do is end it here in terms of opening statements. We'll go into the discussion period, and we'll allow David to start it off. Thank you, Neff.
Great. Timing was almost perfect. That's 10 minutes. Okay, so now we're going to have an open discussion period of about 50 minutes, and then we'll do some Q&A. Tag me with questions at Nephilim Free. I've got a couple already, so make sure if you have a question that you tag me so it's easily visible and I can see it and I can copy it and paste it into my text file, and we can bring them up at the end. So we enter into a 50-minute or so discussion period. Gentlemen, have at it.
Thank you. Standing for truth. I'm going to start. I have a bunch of questions for you. Let's start with this one. After the flood, how long would it have taken for the first recognizable Neanderthal to appear, and how long did they live before they went extinct?
Well, the early Neanderthals were probably more so your Heidelbergensis. Okay, the Neanderthals that we see, the classic Neanderthal features, and the genetics that we have on Neanderthals, the fact that they were the most inbred people group on the planet that we've ever known. Okay, that's the end stage of the Neanderthal. So here's what I would say, okay, to be a little more detailed on this answer. Because Noah was so old, okay, after the flood, he would have passed on an incredible amount of mutations to Shem, Ham, and Japheth. Okay, David, and they would have then went on to repopulate the world. Neanderthals could have been founded by an early biblical patriarch in his old age. But don't think of the end stage Neanderthal. Okay, we're talking about the early stage Neanderthal.
Okay, so question for you then. What evidence is there that Noah or anyone of that age, even it's not even possible to live to be 500 plus years old? There's no evidence for it in any of the fossil record. There's no evidence. We have lots of humans and skeletons from this patriarchal age, and not a shred of evidence that suggests that anyone lived for 120 plus years. So there seems to be more of an assertion. What evidence is there that anyone lived to be 500 plus years old?
A good question. That's why I spent a great deal of time in my opening statement on the evidence for genetic degeneration, okay? Because if we're accumulating roughly 100 new mutations per person per generation, okay? And I've got a source, a paper here from Michael Lynch, a leading population geneticist. He's not a young earth creationist. He agrees, and he's purported that we are declining in fitness every single generation. So David, all we have to do, okay, and to make this understandable to the audience, we take this point of most increasing genetic entropy, okay? This point of greatest mutational load. Take this back to a point in time of least genetic entropy, least increasing mutational load. That would be a point of perfection. Okay, so genetic entropy in and of itself tells us that remove these mutations, let's say 4,500 years ago, you're going to have populations of people living much longer. Plus, we have evidence from the golden age, right? There's legends upon legends upon legends in the golden age, people living to 1,000. Go ahead.
Okay, sure. But here's the problem. These, if you want to appeal to these golden age legends, that's fine. But some of these golden age legends were
I don't only appeal to them.
Far beyond the younger timeline. They lived for tens of thousands of years. I think in the Sumerian kings list, they lived for 200,000 plus years, which we both would agree is completely impossible. So you can appeal to myths and legends all you want, but unfortunately, that's simply not evidence.
So what I would say is the fact that there is a golden age where you see that people are living into, 300, 400, 500, 1,000. Yes, oftentimes legends can be embellished. Okay. But when you've got this large number of stories, large number of legends from all cultures in the world, typically the most parsimonious explanation for this is that they have been derived from a common source. But this isn't my only line of evidence. I'm pointing, real quick. No, David, real quick. So the main line of evidence, though, that I'm pointing to is the fact and reality of genetic entropy that population geneticists recognize is a problem. That's why they're coming up with these artificially derived rescue mechanisms like synergistic epistasis. So my question to you then, since you've asked a few questions, okay? And I want to point out, we have some longevity genes that are broken, that are damaged. You turn those back on in a time where those were not degenerated through mutations, there's a time where people can then live much longer. But also this actually, and here's the point that you had, and then you can take as much time as you need, okay? Because after the flood, remember this, David, and you pointed it out, and I'm glad you did in your opening, there were very small populations, okay? And these biblical patriarchs were then having kids in their very old ages doing what? They're transmitting a huge amount of mutations per generation. So a large branch, and we can pull up a phylogenetic tree if you'd like. I saw you shared one in your presentation. A large branch on a phylogenetic tree could certainly be due to old men having kids, patriarchal drive. That's why you have to fight it. So my question is, what type of selection, what type of mechanism, and I've asked this several times, so maybe now you have an answer, can remove and filter out all these deleterious mutations that are accumulating into our genetics? Go ahead, take your time, David.
Yeah, well, sure. Again, I thought this was going to be debate more on Neanderthals rather than genetic entropy. But that being said, what can be asserted without evidence can be dismissed without evidence. There's still no good evidence that anyone has lived 500 plus years. Well,
now you're tap dancing there, David.
well, again, I mean, it's the truth. You can appeal to myths and legends all you want, but the point of it is there's not a single shred of evidence.
I just gave you a number of lines of evidence. Let's see if you can reiterate some of the lines of evidence I've just presented. I didn't just provide you evidence from legends in the golden age. I've told you specifically, we can go through a number of genes that are involved in longevity that are broken down, and therefore if you go to a point in time where they are not broken down due to mutation, then logically this would be a time where people are living to longer ages. But here's the thing, you have to deal with genetic entropy. It's directly correlated to the Neanderthals and patriarchal drive. That's why you have to address it. You said there's no evidence for it. I've got quotes from Kimura, I've got quotes from Michael Lynch who say that we're accumulating 100 new mutations per person per generation. And the more functional the genome is, the more rapidly our genome is declining. And we know there's at least evidence for 60 to 80% genome-wide functionality. So take your time. I don't want you tap dancing the question. What type of selection or what type of mechanism can filter out all of these mutations that are essentially unselectable, David?
Again, natural selection does just as fine of a job. I mean, but again, let's get back on the original topic of Neanderthals.
Well, this is the topic because you wanted to talk about longevity. What do population geneticists mean then when they talk about effectively neutral mutations? Because if you want, I can screen share a bunch of quotes. I've got one here from Michael Lynch, who talks about these mutations that are so subtle to fitness that selection can't see them, and therefore they are only subject to genetic drift. They're not being removed by selection. Selection can only see the worst mutations, but the majority of mutations, David, are effectively neutral. They're so subtle to fitness. They're so subtle to genotype, okay, like a single typographical error in a text, that selection can do nothing. Selection can do nothing to remove these mutations. Therefore, and I'm going to ask you again, I don't want you, you're doing a good job tap dancing here, David, but seriously, don't dodge the question. What type of mechanism? Obviously, we can't use selection because selection can't see them. So you can't just say selection as an answer. That's a non-answer. How do we remove these mutations? Go ahead.
Okay, well, again, this debate is about Neanderthals, not genetic entropy. I would love to have a separate debate just talking about genetic entropy. And
well, David, you're dodging. We've had.
I'm not dodging the question. I'm trying to bring it back to the original topic, which is whether or not Neanderthals are distinct species.
Right.
So
but I'm telling you that patriarchal drive solves this problem as to why they're different. Okay, Neanderthals are a branch of early man. Okay, they would have started off with more biodiversity. Okay, because they have different sets of biodiversity. They were different. We've lost a lot of genes. These early biblical patriarchs, they were living into, let's say, 300-400 years old. They would have passed on more mutations. Therefore, if Neanderthals were founded by an early biblical patriarch, they would have already started off with a whole bunch of mutations and a different set of biodiversity. You're trying to say that genetic entropy isn't part of this debate, when in fact it is the debate. Because you're denying the fact that we're accumulating mutations. So that's why you really need to address the bigger picture. David, if you want to say you don't have an answer and you want to reconvene on another day on that specific question, then fine. But I don't want you tap dancing and saying that it's not part of the topic of tonight. So go ahead, David, either answer the question or say you don't have an answer, and then we can move on.
Okay, sure. So again, it's not that I don't have an answer. It's that I would rather talk about the larger issue, which is phylogeny and Neanderthals and the topic at hand. And Sandy, let me see if I understand the issue of patriarchal drive real quick. Can I try and steelman your argument real quick?
Yes. But real quick, pause. Okay. Because I have to point out to the audience that you are dodging and you are tap dancing the issue, because patriarchal drive would suggest that the early biblical patriarchs would have lived much longer. And that's directly correlated with genetic entropy, because in the Bible, we see it recorded, an exponential decay curve, perfectly consistent with the biological decay curve that we see due to mutation accumulation. So you can't say that it's not the topic of the debate when it's directly related to the topic of the debate. That's why it's an important issue. And so, yes, you could steelman it, but you still have to address the bigger picture. So yeah, go ahead.
The issue here, steel manning, what I understand is saying is that these patriarchs were living to be 500, 600 plus years old, and they were having children in an old age, which explains why their children were had higher rates of harmful mutation. Is that a proper understanding?
Well, for one, I'd have to ask you this question. How do we explain the origin of genetic diversity?
I don't understand the question.
Well, for example, evolutionists would say that the origin of all DNA differences and DNA diversity is a result of mutations over time. We would not hold to that view. Our starting point, as you know, is created heterozygosity. Okay, so Adam and Eve at creation, as well as the biblical kinds, they would have been front-loaded with all of these DNA differences. So by the time of the flood, and by the time that the Neanderthals were founded, let's say by an early biblical patriarch, they would not have had as many mutations that are deleterious accumulated that you would say according to your model. Does that make sense, right? Because we have different starting points on the origin of genetic diversity.
Well, mutations aren't the only mechanism, but I understand where you're going. But again, I kind of want to get back one topic with is Neanderthals. I would love to do another topic just talking about the issues of selection and genetic entropy. But again, let's go back to what I think was one of the bigger issues here. So how did the population? You said in your debate with Walker that there would have been about 1 in 2,000 people alive at the time of Babel. Correct?
It would have been a smaller population, yes, of course, because we would have been repopulated by 8, right? Noah's 3 sons, Shem, Ham, and Japheth, and their wives. But there would have been rapid and exponential population growth. But by the time of the Tower of Babel, yes, it wouldn't have been a large population as we would have today, of course. So,
all right. So you have, would you agree with the overall anthropogenesis timeline where they had the Tower of Babel about 100 years or so after the flood?
how many years after the flood?
Um,
500?
About 100 according to anthropogenesis and astrochronology.
The Tower of Babel, 100 years after the flood? No, I think it would have been longer than that.
Okay, so you would said probably give me a number or so.
Well, let's say the Tower of Babel was roughly between 300 and 500 years after the flood. Okay. Now, based on the fact that the biblical model would say rapid and exponential growth from that starting point of 8, combine that with patriarchal drive, where you've got all of these mutations pouring in from generation to generation, okay? Adding diversity, essentially, because a mutation, although it's not beneficial diversity, it still adds some diversity because it adds something that was not previously there. Because the population is small and because of genetic drift, that is going to help answer this question that you think is unanswerable. So the small population, you think that it's winning you the debate. But the small population is exactly what we would expect, and it's exactly what we look to explain that different set of biodiversity for the Neanderthals.
Okay, trying to bring this down a little bit. How long would it take for the biodiversity? How long would it have taken? How long did the Neanderthals actually live for? From the time they first appeared to their extinction?
So by the time they were, let's say, founded by an early, okay, so let's say the Neanderthals, they started off different. They started off more diverse. Okay. That's why I want to point out, though, that's why, and if you want to dodge it, that's fine. That's why genetic entropy is important, because we've lost a lot of genes, okay, since those early biblical patriarchs. That explains why we are a lot different. But let's say Neanderthals, okay, already they're starting off different, being an early branch of man. Early man would have been more diverse. And now the evidence suggests, okay, and when we looked at patriarchal drive, the evidence suggests that they would have picked up a ton of mutations over time for a number of reasons, including the fact that they are the most inbred population. And the Neanderthal, the classic Neanderthal that we know today, the genetics that we have that suggests they're highly, highly inbred and on the verge of extinction, that was the end stage of the Neanderthal. And it makes sense because you pointed out that they were living in a time of cold environmental conditions. And we can see that they were well adapted to those environmental conditions. But the end stage, let's say within 1,000 years, okay, we are looking at a subpopulation of human that are extremely inbred, that have accumulated massive numbers of mutations, and they were on their way to extinction. That can happen quickly, okay? Because, and go ahead, take as much time as you need. I'm going to screen share a couple studies that I have of highly inbred populations going extinct quickly due to massive mutation accumulation. I mean, it doesn't take long, David. Are you trying to say that the time frame is not suitable for their extinction or assimilation with modern Homo sapiens? Go ahead. I know I talked a lot there, so take your time as I do this.
And that's one of the problems I'm having here. All of this diversity coming in, going out really quickly. Why aren't Neanderthals or any of the other human species ever represented in art? And why aren't they found in any modern city where they would be considered, okay, these Neanderthals were living in modern cities or whatever?
Here's the thing. They were living in a time where the rekindling and the rebuilding of culture as humans knew it was taking place, right? The Tower of Babel, for example, when their languages were confused. Like today, we rely on other people. I mean, just in my community alone, I've got police officers, firemen, lawyers, doctors, nurses, handymen, people that work in construction, right? All of these fields, all of these skills are divided amongst a large number of people. Now, at the Tower of Babel event, Okay, they're all working together, and all of a sudden their languages are confused. Okay, and then they all migrate to different parts of the earth. Okay, so certain groups of people are going to be lacking certain skills. And that's why what we see in, say, the fossil record is exactly what we'd expect, where evolutionists would look at this and say, look at this branch of primitive man. No, a lot of these people groups that migrated different parts of the earth, they lack certain skills. Not one person has all the skills. Okay, so that's exactly what. So no, we wouldn't expect all of these major civilizations popping up by the time the Neanderthals went extinct. And that's why we see, I mean, we can see Homo naledi, Floresiensis, Luzonensis, we can see Neanderthalensis, we can see evidence for significant inbreeding. I forgot that I was screen shared here. So here we go. Inbred Neanderthals.
So here's the question. Shouldn't
Go
everything be inbred? Shouldn't we be inbred as well? Highly inbred? And would Noah and all, would they have been recognized as like a modern Homo sapien, or would they have been viewed as something completely different? And if they were Homo sapien, why weren't we affected with such the deleterious mutations that the others were?
Here's the
why didn't it affect our lineage, so to speak?
So I'll answer that question, and you can see my slides.
Yeah.
Okay. So here's the thing, though. Neanderthals, as I pointed out, since they signify an early branch of man, okay, we would expect ancient man to be a lot different than modern man. And since modern humans today, okay, they descend, Dave, from only a small subset of the post-flood population. So your so-called pre-humans like Neanderthals, Denisovans, Erectus, Floresiensis, Naledi, Heidelbergensis, who I would say was probably early Neanderthal, the less inbred version. Okay, and here's the thing. We can look at ancient and modern hunter-gatherers today, and their genomes are much more diverse in many ways. Okay, there's been a lot of genes lost over time. Neanderthals are more different because they are earlier, plain and simple. And a lot of these other so-called pre-humans, they are different because they are highly, highly inbred. And the inbreeding occurs due to isolation, okay? Humans today, we are not in isolation. A lot of these subpopulations that broke off after Babel, let's take Neanderthals and the hobbits, for example. They remained isolated, okay, which resulted in significant inbreeding. Inbreeding reveals those deleterious mutations that are in recessive form. They're now manifested. They lead to rapid accelerated genetic degeneration. We can see that in the cheetahs today. And we can see here's a number of papers. Dying woolly mammoths. We're in genetic meltdown. Genetic meltdown in woolly mammoths, for example. Here's a couple papers. High genetic load in an isolated. Well, here's a question that answers it. High genetic load in an old isolated butterfly population. David, how come every single butterfly on this planet then is not showing evidence of inbreeding?
Hold on. Well, I'm
no,
just.
No, I don't want you tapping. I've answered all your questions. So here we have a paper. High genetic load in an old isolated butterfly population.
Okay, let me pull up high genetic load.
How come every single butterfly then on the planet? How come they're not all showing signs of inbreeding, like you say all modern humans should?
I don't think you misunderstood my question. The point I was trying to make is that why is that our lineage was seemingly unaffected while the others were?
I just answered that question, David. Listen. You got to listen here, okay? Neanderthals are an early branch of man. A lot of these branches of man, okay, these side branches, well, what happened? They went into conditions, either post-Babel or pre-Babel, where they remained isolated. And thus, as a result, what occurred was inbreeding and the rapid accumulation of deleterious mutations. Okay. The reason why, are you asking how come we're not in the same type of genetic decline as these side branches? Today, modern Homo sapien?
What I'm asking is, like, with all these Neanderthals and all Homo erectus, Homo floresiensis, all these that we would recognize almost as a completely distinct species with the morphological distinction. Why is it that that's what I'm asking, why our lineage was unaffected by that and why we pretty much stayed the same?
Well, I wouldn't say we're definitely not unaffected by mutation accumulation, right? That's why we can see a massive, massive genetic load that puts a shelf lives on our genomes, and not just ours, other mammals too. There's been studies that show that the majority of mammals have a similar mutation rate. My point is modern Homo sapiens today, we did not go into a condition like the Neanderthals where we remained isolated, highly inbred. I mean, you do realize that Neanderthals are the most
of course.
inbred population that we've ever seen. I mean, Neanderthals, when you sequence their genomes, they've got these massive stretches of identical letters. Okay, which indicates a ton of inbreeding. But here's the thing, this was population wide. Okay, and Neanderthals changed over time. We're looking at the end stage of the Neanderthals, but that's why patriarchal drive is so important, because the question is, it sounds like your biggest problem is the fact that we're looking at Neanderthals who exhibit a different set of biodiversity compared to Homo sapiens, right? And I know Dr. Dan explains it like this. He says what we do is we characterize and then quantify those differences, and that essentially puts the Neanderthals as what? A sister group, as you showed and went over in your opening presentation, as compared to the same species as Homo sapiens. Is that more or less representing your argument correctly?
So I guess what I'm arguing here is that the genetic evidence that we shows is that the genetic evidence, when we map out the more phylogenetics, the Neanderthals are clearly in a distinct clade by themselves, apart from Homo sapien, and that's what I shared in one of my slides. And after this, I do want to.
I want to show you. I want to show you this phylogeny real quick. So here's a basic example. We've got Homo sapiens, but we've got a lot of side branches, either pre-Babel or post-Babel. Can you see my screen?
Yes.
Naledi, Hobbit, right? Floresiensis, Denisovans. So these are all extinct. They're side branches, and they went into conditions that resulted in inbreeding and rapid genetic degeneration. But here's living humans today. This is us today. We are not going to be similar. Well, we will be similar in a way, but we're not going to be identical to your side branches, your hobbits, Naledi, Denisovans, Neanderthalensis, Erectus. I'd put Luzonensis in there. I mean, that just seems basic. And here's the thing, this happens. We have isolated populations of butterflies. This is significant when it comes to genetic entropy, and I'll tell you why. Because inbreeding is a sneak preview into where we are going genetically as a species. And there's no type of selection that can remove all of these nearly neutral mutations that are pouring in, David, from generation to generation. Look at here. Here's a number of studies. Examples of fitness reduction in small isolated populations include studies on mammals, there's seals, reptiles, amphibians, European tree frogs, toads, aquatic snails, plants. I mean, this happens right here. The woolly mammoths, they went into a state of genetic meltdown due to, look, mammoth had an excess of what looked like bad mutations. So here's the thing. Are you not accepting the answer as to why Neanderthals are different? Because if so, in your opinion, steel man my position, what would make Neanderthals different then? Pretend to be me, and what answer are you looking for then? Because the answer I'm providing you in the fact that they were different because they were early man, they would have started off different. Hypermutation and patriarchal drive explains exactly why they are different, phylogenetically speaking. So go ahead.
Okay, sure. So the thing is that if they're hypermutating and highly inbred, those are incompatible arguments. Those are two mutually incompatible claims.
Well, here's the thing. I don't want you tap dancing. I want you to tell me what answer you are then looking for. Because if the answers I'm giving you with patriarchal drive, so you're saying the hypermutation then is inconsistent with the inbreeding.
Correct. And the reason why I say this is because if they were hypermutating, they would be more genetically, they would have more genetic diversity, but they would have very little genetic diversity. We have their genome. It's a reliable genome. Even Nathaniel Jeanson and others claim that, yes, this is reliable genetic data. And The thing is, there is no evidence of hypermutations in the genome.
Okay, so let me ask you this question then. Based on patriarchal drive, based on hypermutation, right? They're picking up a lot of mutations over time. We know that they're the most inbred population on the planet. So we can see a phylogenetic tree, okay? So we would see longer branches when it comes to the fossil sequences of Neanderthals. If that were the case, you're saying there's no evidence, I understand that, but I need to know what answer you guys are looking for, because I feel like the answer I gave can actually answer this question perfectly, solve this phylogenetic problem. If there were evidence for that, patriarchal drive combined with hypermutation over time due to the, let's say, due to the inbreeding nature. And here's the thing, I want to point this out too. If Neanderthals were founded by an early biblical patriarch who was closer to the flood and essentially closer to the creation event, they would have had more superior genetics, which means going into the post-flood world, the post-flood environmental conditions that were harsh and negative as compared to the conditions pre-flood, that would have been detrimental on their genetics. It would be like somebody who lives a life free of fast food, free of junk food, okay? And all of a sudden they go on a, like that movie Super Size Me, you know, all of a sudden they start eating McDonald's, breakfast, lunch, and dinner. They're going to decline in their health quickly. And that's how a lot of these early post-flood populations were, is they decline rapidly because their more superior genetics couldn't handle those conditions. So go ahead. Would this at least answer your question if there were evidence?
Okay, hold on. Let me. I forgot what I was about to say. So here's the problem. When we have a harsh flood, post-flood world, we have Noah and others living hundreds and hundreds of years in these harsh environments. The probability that's happening is, of course, 0, since people don't live to be, the oldest confirmed person was 120. But again, right after the flood.
Yeah, but David, I'm just asking you a simple question. If there were evidence for the patriarchal drive and the hypermutation, would that answer your question regarding the phylogenetics and the fact that Neanderthals exhibit different sets of biodiversity? Because I need to know what you're looking for.
Well, no, because again, the reason why it doesn't is because they were highly inbred, ergo they were not hypermutating. But
I'm saying hypothetically, if the hypermutation were a thing and the patriarchal drive were a thing and they were an early branch of man, they started up, would that answer the question to you? I understand, and then we'll go into the details and see if that's the case. But I need to know if that will answer the question for you, phylogenetically speaking.
No, it wouldn't.
Okay.
It would still be nested within the Homo sapien clade. That being said,
the way the phylogenetics look that way because of these reasons. This is why they are different. David, they would have started off different. We have lost a ton of genes. We've devolved since early man. And you don't want to answer the question of mutation accumulation that all population geneticists recognize, because genetic entropy takes us back to a point in time where we would have had these early biblical patriarchs who are living longer lives because they have less mutation accumulation. Yeah. So that's the bigger picture, and you don't want to answer the question.
Can you share my screen real quick?
Just one sec. Here we go.
So a simple question. Share my screen. When we do the phylogenetics and when we do the DNA analysis, would you agree that this is what we see? Does this map look right? Basically, what I'm asking.
You're going to have to zoom in. So that, well, I've already represented the position correctly in the fact that the Neanderthals exhibit a different set of biodiversity compared to modern humans. So therefore, when you characterize and quantify those differences and you look at a phylogenetic tree and you look at genetic markers that are, say, in Homo sapiens and not found in Neanderthals and vice versa, then that would indicate on a phylogenetic tree that Neanderthals and Homo sapiens belong to separate clades. So yeah, that's what it would look like on a phylogenetic tree. But here's the thing.
So basically, you're saying you agree that it looks like phylogenetically that they look different. Basically, is that what you're arguing?
Here's the thing, though. Here's the thing. I am telling you why that is the case because of the history of early man being so chaotic with everything that occurred in the post-flood world. And that's why biblical patriarchal drive, okay, these really old early biblical patriarchs having kids, passing on a ton of new mutations, Neanderthal starting different. Would you expect them to fall within, for example, all modern humans today, like Africans, modern Homo sapiens? They're going to fit differently on a phylogenetic tree than if you were to bring in Neanderthals, who were a branch of early man. They would have started off different. We've lost a lot of genes and diversity since then.
They would still nest well within the Homo sapien clade. So the problem here, problem being here, is that when we actually sequence the DNA, when we actually look at it, let me find my place real quick, we find that their Y-DNA is incredibly different. So let me pull up my screen real quick. Sorry. Let me share my screen. Share my screen real quick. And
but Dave, I do want to ask you a question that as you're sharing, okay, I see it pop up. My question is, after so many discussions on mutation accumulation, how come what would be your best answer as to how to remove all of these mutations? That, if genetic degeneration is true, which the evidence seems to suggest, it's been verified by thousands and thousands of numerical simulations where you can put in any number of parameters you want. Heck, you can even put in that the majority of the genome is junk, and still it's inevitable. Genetic degeneration. This points us to a time of perfection, a time of creation, and a time of longevity. So therefore, you should at least attempt, okay, to address the issue, the question, because here's the thing. I've given you numerous answers to your questions. And here's the thing. You may not like the answer, and that's fine, but you have to still at least try to answer my questions, David. So at least attempt an answer as to how this problem of mutation accumulation can be resolved. You can't just wave it away like the other evolutionists. You gotta provide some data, David.
Okay, sure. So here's one of the papers that I was gonna point out here. So when we actually look at the genetic data, is that the Y-DNA is very much distinct. We'll start from here. Hold on one second. We estimate that the time to the most recent common ancestor of the Neanderthal and modern human Y chromosome is about 588,000 years. And this estimate suggests that the Y chromosome divergent mirrors the population divergent. And the fact is, the Y-DNA that we describe has never been observed in modern humans. Excuse me, that is not what I wanted to share next. I'm sorry. And when we do the mitochondrial most recent common ancestor between the humans and Neanderthals, it shows that their most recent common ancestor was hundreds of thousands of years ago, well past the young Earth timeline would allow. And again, we also see no evidence of human DNA in Neanderthals, and that's simply not what we would expect if humans were part of the Neanderthals simply were.
See, I want to point out. I just want to point out the fact that you're tap dancing. You're still not answering the question of genetic degeneration, genetic decline, because this takes us back to a time where patriarchal drive, which does answer this question about why Neanderthals exhibit different sets of biodiversity. Not only that, is they would have started off different. They would have started off more diverse. And since they are an early branch of man who then also experienced severe inbreeding and rapid genetic decline, this is why they are different. So you got to answer the question. You have to answer the question.
Are you talking about Mendel's accountant there?
With I didn't even bring up Mendel's accountant in that part.
The things you were bringing up. Excuse me. Sorry.
Well, David, here, I'm going to say it in one sentence. What mechanism? You can't use selection because selection can't see these effectively neutral mutations, okay? So what mechanism can you invoke and provide us today that will be able to filter out all these mutations that are pouring in from generation to generation?
Well, again, back to the original topic of the
This
Neanderthal.
is the okay, yeah, okay. Good. Apply it to Neanderthals because I am taking genetic entropy and I am applying it to Neanderthals and the early biblical patriarchs.
The problem here with Mandel's account and the genetic entropy is that it doesn't match what we actually see. Hold on 1 second. Let me pull up my notes real quick.
David, I've already given a number of lines of evidence that demonstrate genetic degeneration is a thing. We've seen many, many species. I've shown you a number that have gone extinct due to rapid mutation accumulation and due to inbreeding. Now, here's the thing. Inbreeding is a sneak preview into where we are going genetically as a species if you cannot today provide us a type of mechanism that can filter out all these numbers of mutations. So go look at your notes and what answer can you provide? And yes, Mendel's accountant, thousands of simulations have been done, many of them published in mainstream journals and creationist journals. And you can set any parameter you want, and it is still inevitable that genetic degeneration occurs. Now, here's the thing. When you apply generous amounts of purifying selection, okay, when you apply super beneficial mutations, yeah, the genetic degeneration slows down, but it doesn't stop. It's not actually solved. So go ahead, David.
Yeah. The problem here, though, is with the whole thing with genetic entropy and all of that is when you look at harmful viruses and bacteria and stuff like that, they have small genomes and very high mutation rates. So if there was
David, you're tap dancing. No,
I'm
listen,
not.
I got it. Yes, you are, because now you're going to bacteria, which I've already answered in our last discussion as to why that does not apply, nor has it ever been predicted that bacteria would go extinct first.
Well,
You're
I'm not
tap
saying that.
dancing. I'm not going to answer the question. What type of mechanism can be applied to humans? Okay. Here's a simple question. Do you believe that humans are getting better as a species? Are they improving?
Define better. Quantify it for me.
Are we improving? Are we seeing less disease? Are we seeing less mutations overall?
Well, overall, yeah.
We're seeing less mutations overall?
With the help of vaccinations and modern medicine and all of that, yes.
Okay. Modern medicine being applied to humans. Okay, for example, when we get diseases where if it was natural selection at play, because we've removed natural selection. We've removed natural selection in humans because we take care of the sick, right? We apply. What if we were to remove the medicine? What if we were to remove the fact that we take care of each other and take care of the sick? What do you believe would happen?
Well, of course, there would be a lot more deaths, and that's one of the selections in humans is that we do take care of the dead, and that we, take care of the sick, and that we do take care of each other. If you're asking for what type of selection happens in humans, well, yeah, modern medicine and the ability to help each other and sustain each other, yeah, that is one of the mechanisms.
But what if we were to remove those factors?
Well, yeah, if we remove those factors, then there will be a lot more deaths due to viruses and sicknesses. And that's the great thing about vaccinations is that it has wiped out many of the diseases that.
So you're missing the point. So in the wild, okay, because I've got a paper here that I can screen share where nearly all mammals have a similar mutation rate. Okay, so every mammal, including humans, are accumulating more and more mutations. For example, David, you and I, we have 100 more mutations than our parents. We have 200 more mutations than our grandparents, and so on and so forth. So here's the thing. Over time, we are accumulating more and more mutations. And even if we've got 8 billion people on the planet, let's just say you were to wipe out, okay, 4 billion of the worst mutants. Now, we're all multiply mutant. And remember, selection acts on phenotype, not genotype. So get rid of the 50% of the worst. Well, now you're still left with 4 billion people who are more mutant than the generations prior. Do you see how consistently we are more and more mutant, regardless of how much selection you invoke? Now, here's the thing. You can't invoke too much selection because if you remove 80% of the population, now you've got a population that's so small that mutations and genetic decline will occur too quickly. So how do you solve that problem? The fact that no matter what you do, no matter how much purifying selection you apply to a population, we are getting worse and worse over time. How do you answer that?
Let me interrupt a second before David says his next bit. Just to remind you, we have 7 minutes left. Go ahead.
Okay, sure. So I guess I'm going to try and get in as many questions, kind of go back with the issues of whole with genetic entropy and all that.
Are you gonna answer that question though, and then I'll let you ask a question.
And so I'll go with the issue of genetic entropy real quick. The point I was trying to make with bacteria, viruses, and other organisms is that even if we cannot apply the same thing mathematically, we should still be seeing them accumulating harmful mutations. One of the big things, of course, coronavirus, and we see headlines of this rapidly mutating, is, of course, the first thing we see as we are afraid. We see, okay, this virus is rapidly mutating. That should be a good thing under the genetic entropy model, because if that means harmful mutations are still going to be accumulating, and therefore there's still going to be an overall rapid decline. The fact of the matter is,
the best thing that could happen to it would mutate to oblivion. That would be the best thing that.
Exactly.
We've seen it.
I'm trying to make.
Yeah, but here's the thing. We've literally seen it with the H1N1 human version. Okay, that virus. It went from a red hot pandemic to a whimper to an extinction event in 90 years. This is published in a mainstream journal where it was observed that there was an accumulation, a linear accumulation of mutations where codon bias declined consistently over time. That's not consistent with adaptive evolution that some people have tried to look to. Yeah, now that, there's been some critics, of course, criticizing that paper. But here's the thing. This is a paper published in a mainstream journal. So if you got a problem with it, then go write up your critique or go point out the problems with it and get it published. And you want to talk about bacteria. What's funny is genetic entropy has never predicted that bacteria would go extinct first. But okay, guess what? Are you familiar with Lenski's experiment? Are you familiar with... Oh, go ahead, David. Go ahead.
Genetic entropy is that genetic entropy has never been observed. And the thing of it is...
I just gave you a case in viruses that it's been observed.
The thing is, even if we say that bacteria and viruses not predicted to go extinct first, okay, fine. The point that I'm trying to make is that they should still be accumulating harmful mutations and that they should still...
David, you just dodged everything that I said about the H1N1 human version. How do you explain the fact that it's been published in a mainstream journal, okay, that there was a linear accumulation of mutations that took this H1N1 human version, this virus, it took it from a red hot pandemic to a whimper to an extinction event in 90 years observed in viruses? How do you explain the codon bias, the fact that it declined consistently over time? How do you explain that according to your model?
Again, one of the big things being the vaccinations that we had. But the thing is here...
what are you talking about, David? You're tap dancing all over the place. Answer the question that I just provided you about the H1N1, the human version that went extinct due to genetic entropy. That's not evidence for you? You just said it doesn't happen in viruses. And I'm saying that, yeah, okay, with the new virus that we have, the best thing that could happen to it is that it would mutate to oblivion. So how do you... listen, I gotta hold you to the fire. How do you answer the fact that codon bias declined consistently over time, showing that the H1N1, the human version that is, went extinct due to genetic entropy?
Okay, sure.
Answer that question. Just stick on that question.
Okay, sure. So I'll just respond real quick, quoting here from Dr. Dan. So the whole point of the paper was that the H1N1 fitness declined over time due to genetic entropy. Fitness for the viral genotypes in question was not directly measured. Correlates of the fitness were not directly measured. Fitness was evaluated based solely on two extremely poor proxies. Codon correlates with host and virulence. We can relegate...
David, I'm not just going to let you read word for word what Dan said. I want you to critically think, okay, here's the fact. The virus started off more human in its codon usage, David, okay? And what it ended up, do you know, because you're just going to quote Dan blindly, tell me, the virus started off more human in its codon usage. How did it end up?
Not sure.
It ended up more randomized. So read the paper with an open mind, okay? It became worse, David, at interacting with human DNA over time. And if it is using the wrong codons, that means it will be less efficient at replicating in human hosts. Okay, this is a decline in functionality and matches exactly with genetic entropy. Don't quote, you could quote Dan, but I don't want you just reading some massive paragraph without even understanding it and addressing the key issue. So what I just said, answer that question. Give me an answer from the brain of David. If you don't have an answer, then just say you don't have an answer and we can reconvene.
Okay. Well, again, codons simply do not interact with human DNA. As Dr. Gian just pointed out properly, codons don't interact with human DNA. But that being point, how much time is there left for this?
2 minutes.
How many?
2 minutes. We could go 5 if you guys want.
So
yeah, maybe give another 10. Wait, because I want to leave no stone unturned, and then I know you had a question about the interbreeding, the hypermutation. I do want to answer all your questions, but one thing that's hanging is bacteria. So how do you explain the fact that in the Lenski experiment, what we've observed is just that? Reductive evolution. Lenski's own data has revealed clear evidence of genetic degeneration. His populations of E. coli bacteria, they have shrunk in functional genome size. They have painted themselves into a corner. So how do you explain that?
Incorrect.
No, that is okay. But then give a rebuttal. Why is that incorrect?
No, again, I kind of want to. How is that genetic entropy from your point?
David, reductive evolution. Okay, the fact that these beneficial mutations, okay, observed in Lenski's experiment, the fact that what we've observed is loss of function, loss of promoter, loss of genes, loss. What they've done is they've gotten rid of genes short term, but it's long-term degeneration, okay? It's like if I was driving a car and temporarily I wanted better gas mileage, so I wanted to remove weight off the car. So I decided to remove the doors, remove the side mirrors, remove some of the seats. Yeah, temporarily I'm going to get better gas mileage because the car weighs less. But guess what? It's not improving the car, nor is it explaining how the car was built. That's exactly what we're seeing in Lenski's experiment. We're seeing reductive evolution. Genes are being lost short term. It's long-term degeneration. How do you explain that?
Okay, but again, that's not what the data actually found. But I think the important thing to remember is that yes, and microorganisms.
Wait, are you denying? I've got the paper pulled up here. Are you denying the fact that Lenski's bacterial populations have shrunk in functional genome size? Are you denying that? I want you to go on record and say you deny that.
What paper are you citing?
Have you read any of Lenski's papers?
No, I have not.
Okay, well, then there you go. Go read his paper. There's a new one in 2020. Okay, that's showing that there's been no forward evolution. You are making a claim that this is wrong. You are making a claim that Lenski's own data has not revealed clear evidence of genetic degeneration with no argument. You haven't given an argument to the H1N1 virus. You haven't provided us a type of mechanism that can remove all these deleterious mutations. I have answered your question sufficiently when it comes to the biodiversity of Neanderthals, the fact that they're a branch of an early man. You said, okay, you can ask a question then. You can ask your contradictory question with hypermutation if you want.
All right, so let's just go back to the original topic, which is Neanderthals. I feel like you kind of did this to try to force me into a debate on genetic entropy when you were.
No, but you're tapped in. I gotta call you out, David. I gotta call you out. Genetic entropy takes us back to a time of increased longevity. What was my main argument for why Neanderthals were different? Go ahead. What was my main argument? Let's see if you can reiterate it.
And they were hypermutating, they were highly inbred, and that they were a product of the patriarchal thing. Can't remember patriarchal
drive. The fact that you had early biblical patriarchs living to extreme ages, passing on. The longer you live, the more mutations you're going to accumulate in your somatic cell lines. Those are not passed on, but the more will be passed on through your germ cell lines, your reproductive cell lines. Therefore, if Neanderthals were founded by an early biblical patriarch, they would have started off different. And they were already different because early man would have been more diverse to begin with. That's why they are different. And you just don't want to accept the answer. And for some reason, you seem to think that hypermutating anyways and inbreeding is a contradiction. Why is that a contradiction?
Okay. Well, because again, we have their genome. Hypermutating and highly inbred are two mutually incompatible statements. It's like saying up and down. It's literally it's literally not even wrong. That's the problem. It's not even wrong.
Okay, I asked you this question before, and so I'm going to ask you it again. And what's good is this time you've studied. Which genome compartment is larger, the nuclear DNA or the mitochondrial DNA?
The nuclear DNA.
Okay, therefore, what DNA compartment would be most influenced by hypermutation? Would it
Uh,
be the uniparentally inherited DNA or the biparentally inherited DNA?
the biparental, I believe.
No, hypermutation.
I'm sorry, I'm misunderstanding the question.
So the hypermutation, okay, let's go with the inbreeding, the reductions in heterozygosity and the increases in homozygosity.
Okay.
What DNA compartment would that have the largest effect on?
I believe the Y DNA. I mean, I'm sorry. I need some more coffee, but again,
well, here's the thing. No, I'll just give my rebuttal to this. So you're set instead of just cross-examining you on it. Okay, here's the thing. The answer to your question would be when it comes to, and then you give a rebuttal. You can have the last word on it, and then we'll go to closings. Okay. So it's not contradictory, and I'll tell you why. Okay. It's because the uniparentally inherited DNA, that's the non-recombining DNA, right? Hypermutation would have the largest effect on the mitochondrial DNA and the Y chromosome DNA, okay? When it comes to the biparentally DNA, which you answered it correctly, the nuclear DNA, it's larger, okay? The increase due to hypermutation, David, it'd be virtually undetectable. For one, created heterozygosity would apply. You don't want to argue against our model by assuming evolution. You don't want to argue against evolutionary creation, of course. We don't assume the vast majority of nuclear DNA differences were the result of mutations over time. The Neanderthals would have still had millions and millions of created DNA differences. So this is what I'll say, and then you can give a rebuttal. The corresponding increase, okay, David, due to the hypermutation would be practically invisible to detection because we know the nuclear DNA has high levels of homozygosity in the Neanderthals. You're right, they were highly inbred. They had reduced levels of heterozygosity, increased levels of homozygosity. So this inbreeding would have impacted the nuclear genome the most. Inbreeding and the resulted increases in homozygosity would have the biggest impact on the nuclear DNA. So here's the thing. It's not a contradiction. It's entirely plausible to have what? Biparentally inherited DNA, the nuclear DNA, be less diverse than modern humans, and uniparentally inherited DNA be more diverse. Go ahead.
well, Dr. Nathaniel Jeanson disagrees with you.
I got to point out something. I actually talked to Dr. Nathaniel Jeanson about that, and he confirmed that the answer I just provided you was accurate. So why are you bearing false witness on me? He literally clarified with me that was an accurate answer.
I would love to hear
2 minutes, gentlemen.
I would love to hear what Dr. Nathaniel Jeanson says about that. But anyway,
well, you just said that he disagreed with that, but I actually had correspondence with him where him and I talked about exactly what I just said, and he said, "Yeah, that's correct. That's the case. He's got a PhD from Harvard. Does he not understand these topics? Do you think?" So your rebuttal. Your rebuttal. Just for the audience, because it is a debate. And here's the thing, it's been cordial, it's been respectful, but it's also a debate, right? So we got to point out when we are wrong. We got to point out where questions might not have been answered. So everything I just said, your answer was Jensen disagrees with you. When I actually personally talked to Jensen about that, and he agreed with it. So you want to try again?
I would love to hear. I would love to see the correspondence and love to hear what Dr. Daniel Nathan said. And screenshot the quick page real quick.
Actually, David, if you want to go, so what I'm going to do here, okay, because I want you to take as much time as you need. Because I wrote down a bunch of things that you said in your opening statement, and I feel like let me see here. Yep, I feel like I answered it all. I answered all your objections. So here's the thing. Take as much time as you need now. Take the last minute or so to address whatever you feel like was not addressed, and then go right into your closing. And how many minutes do we have for closing?
Yeah, I feel...
yeah, go ahead. Take your time. Take your time.
Just a couple closing remarks. After show on my channel tonight, I feel like this debate was more on genetic entropy than it was on Neanderthals. That being said, a lot of questions that I think we just didn't really have time to get into with the short hour and a half debate. some of the questions that I would still want to have answered is the time scale, some of the dating methods, such as through thermoluminescence dating and other dating methods. We can talk about that maybe at a later time. Again, come on and I hope everyone joins my after show or John's after show.
Okay, gents, is that about wrap it up? Oh, I'm not hearing you guys. Do you guys hear me? Hello?
Yeah, I can hear you.
Oh, okay. So that about is that about the wrapping up the open discussion period, and we can move on then, I suppose, to question and answer. Looks like Standing for Truth is muted. I guess he stepped away for a second. Something.
Yeah, no, I'm here. I thought David was going to take his full. So I ran up to get a drink of water. So if that's all you have to say, I'll give my closing then.
Yeah.
So,
Okay,
David,
so
did you have
for
something to add, or are we going to go on ahead? Go on to the closing statements then?
I guess you could go on.
Okay, so closing statements. Since David started, David's closing statement comes first, then Standing for Truth.
So, David, are you done with your closing? Did you want me to just go?
I was pretty much just done. Everyone joined my after show. I feel like there was this debate was more about genetic entropy than it was Neanderthals. That's how I feel, at least. But anyway.
Okay. Well, if that's all you got to say, then I will. I'll go here and okay. So I'll start off my closing because I've seen a couple people in the comment section, and I've personally talked to Dr. Jensen about the hypermutation and the inbreeding, and he clarified that the answer I provided was correct, and he even assisted in providing additional points, which I provided today. So to say that he disagrees with that, which he's reviewed and even contributed to, it's just like, I mean, is this Twilight Zone or what? Anyway, so genetic entropy, okay, is directly correlated to Neanderthals. Because here's the question of the debate. Are we looking at devolution or evolution? Because my argument tonight in explaining the Neanderthals' different sets of biodiversity compared to Homo sapiens, okay, when we actually characterize and quantify those, I pointed to the fact that Neanderthals were an early branch of man. They could have been founded by an early biblical patriarch. And when you apply patriarchal drive, where they're living longer, okay, because guess what? Today, we are at a point of most mutation accumulation, most genetic entropy. Take that point in time all the way back to creation where we've got no mutations. That's a point of perfection, Adam and Eve. Take that back to a point right after the flood. We've still got people living 200, 300, 400 years. Can you guys, I'm hearing some background feedback. You guys can hear me?
Yeah, we hear you. Keep going.
Okay. So now here's the thing, David, we've had numerous discussions on genetic entropy, and David, just like the other evolutionists in who battle against genetic entropy, they constantly say that it's not a problem, it's not real, they want to wave it away. But then when you get them into live discussion, they got no answer. You provide evidence. Okay, but here's the thing. You can take a horse to water, but you can't force him to drink. So there's been a lot of genes that have been lost over time. And Neanderthals, I mean, they were different because they were earlier, and they were also subject to harsh environmental conditions that would have resulted in their genetic decline. Okay, and I want to point out a fact that every single argument against genetic entropy has been dealt with. And there's a new paper here where Sanford, Carter, and Paul Price demolish the critics. Demolish them. Okay? And this whole mutation count mechanism, which they're looking to now, okay? And David did not even really give an answer. But if he would have given an answer when it comes to natural selection, equilibrium, there's a couple of other responses too. I'd recommend reading through this. I've done a stream on it too. And you will see no matter what, okay, no matter what, genetic degeneration occurs. And I like this quote here. The point of genetic entropy is that the least bad in one generation is actually a little more bad than in the generation before. That's why you can give them whatever they want. You can give them any amount of purifying selection, but it's still inevitable that selection, okay, and all these other numbers of factors, all they can do is slow down the genetic degeneration. All they can do is slow down genetic entropy, but it can't actually solve the problem. And I just wanted to go to Dr. Sanford's comments here. Here we go. And I'm going to end it with this. If an individual carries just one near neutral mutation, it might be very weakly selectable, but probably not, as environmental noise will override its tiny effect. So there will be little or no selection at all. If each individual has 10,000 near neutrals, selection has to try and select for or select against all 10,000 conflicting mutational fitness effects simultaneously. 10,000 independent mutational fitness effects, usually bad ones, vanishingly few good, will not just be pulling in different directions with each other, they will act as noise, blotting out the fitness effects of each other. Haldane makes it clear that only a few mutations can be effectively selected for simultaneously. Trying to select for too many mutations, and I talked about this during the debate, at once totally overwhelms any type of selection. Indeed, selection interference not only prevents selection for countless near neutrals, it even interferes with selection for the more impactful mutations that are also accumulating. I'm going to wrap it up here. What we see is devolution. We don't actually see forward evolution, and Neanderthals are far better explained in the biblical creation model for the large number of reasons that I provided today. And David's main objection that hypermutation and inbreeding are inconsistent and contradictory, I buried that argument at the end of the discussion, and there was no rebuttal. So that's all I got to say. Thank you so much, guys. We'll do a quick Q&A, maybe get to the super chat, Neff,
Real
and
quick,
we'll do some after shows.
before you go, before we get to Q&A, since you and Dr. Dan are both here, I know Dr. Dan has offered numerous times to debate you on genetic entropy. I was wondering if you guys were going to do that or not.
David, we are doing a debate right now between you and I. If Dan and I are going to set up a debate in the future, we will correspond with each other, and I will make sure that there are some. We will debate on format and structure just to make sure that it's a debate where we're both putting forth our arguments, and Dan is not dodging, because we gotta prevent his dodging addiction. So that's my answer to that.
Okay, we're going into the Q&A now. We've got quite a few questions here. So the first question comes from Redefined Living, and the question is for David Neff. Haldane's dilemma, and how do you respond to it?
I'm not exactly sure what that is right off the top of my head.
Haldane's dilemma. Okay, Haldane's dilemma related to the slightly deleterious effects of random mutation and how populations can be sustainable over a vast age of time. This is one of the earliest dilemmas in the history of genetics. Since you don't want to have a response to it, we'll give Standing for Truth a quick response, and then since the question was for you, you can give one. If you don't have a response, we'll go to the next question. Standing for Truth, quick comment about Haldane's dilemma, or no?
Sure, yeah. Haldane was a leading population geneticist, and he actually realized, this was a good question from Redefined Living, he realized that even if there was an abundant and ongoing supply of beneficial mutations, natural selection has limitations, and it must be extremely limited in its ability to amplify those mutations to the point of where they are actually fixed within a sizable population, because fixation rates are incredibly slow, and there's a huge waiting time problem for ape to man evolution, because there would need to be tens or even hundreds of millions of beneficial mutations that arose and then went to fixation within that time frame. Since the split makes evolution impossible, and Haldane wasn't a young earth creationist, and he even recognized this problem. That's it. Okay, so the next question is from is for both. This question was from well, there's no name here. Well, the question, I don't know why it's not a name. Anyway, the question is for both.
Why is evolution called a science when it cannot be observed, demonstrated, tested, or repeated? So I'm going to, since David went first in the debate, we'll let David respond to it first, then Standing for Truth. Any response to that question, David?
Sure. So evolution is science because it has been observed, and it makes testable predictions that have come true. But the biggest piece of evidence for evolution is how applicable it is and how useful it is, and across different fields of science such as medicine, ecology, food science, etc. Without the theory of evolution, nothing in biology would make sense. So that is why evolution is considered science.
Okay, let's keep these responses relatively short if we can, both of you. Okay, so Standing for Truth, do you want to respond to the question, why is evolution called science when it cannot be observed, demonstrated, tested, or repeated?
Yeah, I'll be quick. I think it's an obvious answer. The word evolution can mean many different things. So if we're just looking to the word evolution as meaning change over time, or a change in allele frequency in populations over time or over generations, a change in allele frequencies, or those types of microevolutionary changes, where you get a change in the frequency of the expression of different traits that we typically talk about, that will only explain the survival of the fittest and not the arrival of the fittest. So no, it's not going to explain your pond scum to people evolution, your fish to fisherman evolution. Okay, it just explains the small scale variation. But where's the evidence for the major innovations or the major new structures, major new life forms? So no, that large scale evolution, which is different than just microevolution, that is not science. That's not repeatable. That's not observable. So you got to define terms, and that's it.
So if I could respond
Okay.
real quick.
Well, the question was for both. You've both given a response. We're moving on to the next question now. Okay, the next question is for Standing for Truth from Luca Medugno. The question is, can you show us the 3 branches of the unrooted tree?
Okay, they want me to show a.
I think, are they talking about the genomes of Shem, Yaphet, and Ham? Is that what he means?
I want to point out here. I've got here. I'm going to screen share real quick because I showed a couple trees during my presentation. So here we go. So I'm screen sharing. Here's a Y chromosome phylogenetic tree. I could also scroll down even further and show you a mitochondrial DNA tree. And you'll notice a starburst pattern. And you'll notice that overall, there's only a few mutations. The critics, Team Dodgeball, I love them. But they dodge, duck, dip, dive, and dodge all over the place because they never answer the pattern. They never answer why there's so few mutations. Listen, Neff, there are only a few mutations that separate any person on this planet from the Y chromosome Noah sequence. And there's only a few mutations that separate any person on this planet and the mitochondrial Eve consensus sequence. Now, they want to scoff at the unrooted. Well, if they've ever read the papers, but remember, they read the papers blindfolded. Dr. Carter points out an unrooted neighbor joining phylogenetic tree of the Y chromosomes. That's this one, okay? And he points out that, note the clear central starburst, okay, which consistent with our model. He points out where the evolutionary route would be. It's located midway along the A1 branch. Okay, now here's the thing. He points out that the unrooted representation allows for a more natural reading of the data. And when we allow for a more natural reading of the data, okay, and everything that I discussed about destroys the assumptions of ape to man evolution when it comes to molecular clocks, and they don't want to address the data itself. They've never read the Young Earth creation technical literature where Carter explains this. Okay, and he's even published on mitochondrial DNA in mainstream journals. So, yeah, that's the unrooted tree. And if I had time, I'd show you the mitochondrial DNA one as well. Go ahead.
Okay, David, do you have a response to that? And if you do, then we're going to give it back to Standing for Truth for a very, very brief.
Just move on. Yeah, just move on.
Move on. Okay, the next question is from Gutsick Gibbon. It's for both. The question is, how do you reckon with the fact that dozens of Mesopotamian cultures corroborated dates that preclude the global flood and thus Neanderthal coming from humans? So let me ask it again. How do you reckon with the fact that dozens of Mesopotamian cultures corroborate dates that preclude the global flood and thus Neanderthals as coming from humans?
So yeah, that's a great point from Erica. The fact that we do have all of these ancient civilizations completely unaffected by a global flood that's supposed to wipe out everything is very solid. Is pretty solid evidence against the flood. Yeah. Standing, you have a response?
Yeah, my response would be that that's not a very good argument, because when it comes to written records, when it comes to the direct lines of evidence and the direct observations, history only goes back a few thousand years. And when we actually corroborate that with the genetic data, now we're looking at a Y chromosome ancestor where every single male Y chromosome on this planet is nearly identical, incredibly low variation. Same thing goes for the mitochondrial DNA. So no, humans have originated just a few thousand years ago, and written records corroborate this. And the fact is, all of these cultures around the planet, they've all got flood legends, dragon legends, legends of the golden age. And guess what? Those can all be traced back to a common source, that common source being the Bible and Genesis.
Okay. So next question comes from Just a Walking Fish. And the question is for Standing for Truth. Could you explain the difference between neutral theory and nearly neutral theory? What equation is the foundation principle for NNT, nearly neutral theory?
So good question. So neutral theory of evolution would just have to do with these mutations that build up that are essentially assumed to be neutral. They've got no deleterious effects at all, and they build up and they're subject to genetic drift. And when it comes to evolutionary advancement, right, this hidden reservoir of genetic diversity, the buildup of neutral mutations over time, can be used for change, for adaptive purposes. You know, the descent with modification that the evolutionists would look to. But the nearly neutral, the effectively neutral, that's the thing. That's the thing, is the evidence suggests that there's no strictly neutral mutations, but there exists a class of mutations that I've been talking about with David here called effectively neutral. John Sanford calls them nearly neutral, where those effects of those mutations are so subtle, okay, that they can't be seen by selection, and therefore they accumulate in populations over time, and they're not useful like neutral theory would want, right? They want these mutations to be absolutely neutral, where there's no effects, there's no harm, the mutations are absorbed by the junk areas, making them absolutely neutral. No, they're nearly neutral. They slowly degrade, they slowly degenerate, they accumulate. Selection can't do anything about them. Large-scale evolution is impossible.
Okay, David, do you have a response to that question?
No response, just move on.
Okay. All right, the next question is from Creation Myths. For Standing for Truth, why do Neanderthal nest separately from Homo sapiens?
Wasn't that the exact question of the debate that we had?
Yeah.
I mean, if you want me to go over my entire rebuttal again, I will.
Okay,
I mean,
so yeah, I think you you adequately discussed that throughout the debate. But he asks an aside. He says, if he wants to debate genetic entropy, I'll take time for him. Oh, so it sounds like a challenge. Put the gloves on. Looks like we've got a challenge from Creation Myths.
Debate number 102.
If he wants to debate genetic entropy, I'll make time for him. Ooh.
Yeah, I'll gladly moderate that debate.
That sounds like I dare you to knock the chip off my shoulder.
So Creation Myth says that I didn't give an answer. Well, I mean, if you want me to take a couple minutes and explain the fact that
we'll save that for another time.
The fact they were different, they started off different, they were subject to hypermutation, inbreeding, and we didn't even touch on the fact that mutations to DNA repair enzymes, which was the case, due to the fact that they were the most inbred population that has ever existed. So when you get mutations to these DNA repair enzymes, guess what? More mutations accumulate from generation to generation, which helps explain why purifying selection has broken down. You can read this in secular papers. Selection has broken down with the Neanderthals, which resulted in their extinction and the rapid genetic degeneration of their Well, they're humans. They're just a side branch. So I'm not going to say different species. They're made in the image of God. They're just different because they had different population history, different environmental conditions, different mutational events. I mean, that's the answer to the question. But here's the thing. The evolutionists are not going to tap out because they think this is their knockout punch. No, it's been answered. It has answers. It's the evolutionists that don't have the answers to mutation accumulation. So in a nutshell, that's what I got to say.
Okay, David, do you have a brief response to that?
No response. Just
Okay. Next question is from Sorovision. Anyone who says genetics discussion is not related to Neanderthals discussion is being dishonest. Okay, it's not a question, just an observation, apparently.
I would agree with that.
Okay, moving on. Just a Walking Fish asks another question for Standing for Truth. If Neanderthals are descendant from Heidelbergensis, why is Heidelbergensis more basal by your model more degenerate from Neanderthals? Why did they become less over time?
The classic Neanderthals we see, the genetics that suggest they were hypermutating, that they were on their way to extinction with their classical features, are different than the Heidelbergensis. And if he's saying that some of the Heidelbergensis fossils that we have are more degenerate, I don't know if they're more degenerate than Neanderthals. I find that hard to believe, but it is plausible that a type of Heidelbergensis, the hominid that is named Heidelbergensis, could be an early Neanderthal. The question is, do we have the genetics of the early Neanderthal before they went into those conditions where they experienced rapid and accelerated genetic degeneration? Because that's what we're looking at. That's the genetics of the Neanderthal that we're looking at, is the Neanderthal at their end stage. So therefore, what did they look like? What was their genetics like in the immediate post-flood world? There's been studies that Raw Matt has where they've looked at the D loop, which is a highly conserved mitochondrial DNA region. He can explain it a lot better than me. But apparently when they lined up the D loop in the mitochondrial DNA, which is the control region, and modern Homo sapiens and our D loop, apparently the Neanderthals had way less mutations than we do today, suggesting that they were superior in every way, shape, and form. So that's pretty good evidence. That's pretty good evidence to me.
Okay, so he has. Do you have a response to that, David?
yeah, sure. So in regards to Homo heidelbergensis DNA and Homo erectus DNA, I think that's a very good point. We do not. And I think the obvious question, obviously this could be a topic at a different time, is why? Why don't we have their DNA? If they're all 4,500 years or younger, their DNA should be abundant.
Well, that's easy.
Okay. Well, you want to try and answer that real quick? Go ahead.
Yeah. I mean, that's easy. Like for Neanderthals, look at the conditions. Look at Denisovans. Look where they're found. Look at their conditions. Much easier to. I mean, they lived in the cold environmental ecosystems, the post-flood ice age, for example, which means their DNA is far easier to preserve. The fact that we have their DNA and it hasn't degraded to the point where we can't really get any reliable data suggests that they're not hundreds of thousands of years old. Makes sense if they're just 4,500 years old. But your erectus and a lot of your other so-called pre-humans, they are found in locations that are not exactly as helpful in preserving the DNA where it can be reliable. So it depends on the environmental conditions, and Neanderthals existed at a time and in environment where it makes sense that their DNA could be preserved a lot better.
Okay, so the next question then is, let's see, for Standing for Truth, how can lineage be highly inbred, low heterozygosity, and also hypermutated when Jensen says mutation rate and heterozygosity are highly correlated?
So Dr. Jensen's exact words are mitochondrial, well, not exact, I'm summarizing, but close enough. Mitochondrial DNA is less diverse due to Neanderthals being, the mitochondrial, which I talked about in great detail, the mitochondrial DNA can be less diverse because it's more affected, okay? Because we're comparing them to modern humans today. So is their mitochondrial DNA less or more diverse than modern humans today? The hypermutation would have a larger effect on mitochondrial DNA, and the inbreeding would have the greatest effect on the nuclear DNA. And he corroborated that. He said absolutely right, and he even helped contribute to that. So it's not contradictory. It's not contradictory at all. And if Jensen corroborated it and agreed with it, then Jensen's not contradicting himself. That wouldn't make any sense.
Okay. David, in response? David, are you there?
Oh, I'm sorry. I forgot I muted myself.
Did you want to respond?
No response.
Okay. Next question. The next question is from Doki Doki Bible Club. Thank you for your $5. Do you change schools if Colorado professor is a creationist, David? This is for David. Do you change schools if your Colorado professor is a creationist?
Well, I highly doubt my professor at Colorado will be a creationist, but even if he is, I'm not going to change schools just because of that.
Okay. So next question for Standing for Truth. What's the difference between genetic entropy and genetic meltdown?
So genetic meltdown would be, for example, I showed a number of papers here with the mammoths and the genetic meltdown that occurred due to the isolation and the fact that they were highly inbred, small population where these alleles drifted into a homozygous state. Okay, so that will reduce levels of heterozygosity and increase levels of homozygosity. Now, here's the thing. These are small populations, okay? So with the inbreeding, because they're decreasing the genetic variation because of the increase in homozygosity, there's a stronger chance that the recessive allele that is deleterious will then pair, okay, together in that small inbreeding population than the larger inbreeding population. So today humans exist as a larger population. We have 8 billion of us. So I always point out that the inbreeding is a sneak preview into where we are going genetically as a species, because all selection can do is slow it down. Now, yes, it's going to take a lot longer than in a small inbred population where they're mating with each other, you know, relatives mating with relatives. But I pointed out the fact that you can remove 4 billion of the most mutant people on the planet today, and you're still left with 4 billion people who are more mutant than the generation before it. So that's the difference. It's just a sneak preview into where we are going.
Okay, David, do you have a quick response to that?
Nope. Just curious how many questions we have further.
Okay. There's about 10 more.
Okay.
8 or 10 more.
Not a problem. I was just curious.
Okay.
Well, Neff, if you wanted, so have you gotten the super chats and super stickers out of the way at least?
Here's the deal. We've got Doki Doki has been tossing $1.49 your way about a half a dozen times.
That's a lot of coffees for me.
Yeah, and that's right. A bunch of coffee. $2 one time. He wants you to get that Starbucks, and $5 one time. Doki Doki did say $5 with a picture of a fox laughing. Very cute. And let's see. There's been. Let's see, what else is there? There's a lot of Doki Doki. He dropped down to 99 cents on that account. Or she did. Okay. So Doki Doki loves to play games, bounce it around, keep you on your toes.
Doki Doki's the super sticker master. So
yes,
well, here's what I'm saying.
Doki
So
is.
It's up to you guys. Since we're going on 2 hours, I think we've had a pretty good Q&A.
A Stupid Horror Energy sent $5 with a question. And
Thanks,
so did Jungle Jargon, also sent $5. Thank you, guys.
Why don't we get through whatever super chats are left, and then since there's a bunch of after shows taking place where I think people are probably dying to get in on the discussion for an open mic Friday, maybe we will call it a night since it's at the 2 hour mark. As long as we get the super chat, super stickers out of the way, it's up to you guys. What do you guys think?
Well, we've done that. Doki Doki is the king of in numbers, you know, 1 every 17 minutes. So
I think when Doki Doki puts forth the 99-cent ones, that's when Doki Doki's unhappy with my performance.
Oh.
If it's a $2 one, then Doki Doki's thinking, nice, SFT, good argument. So, but no, thanks so much.
There's another one at $1.99. That's a little better. You're getting better. That's another Starbucks on the way. They're paying half of it anyway. Okay,
Well,
thank you so much, you guys, for the super chats. Again, I mentioned Jungle Jargon, Stupid Horror Energy, both gave $5, and so thanks, guys. Doki Doki also gave $5. So there's about eight or nine questions to go. Unless you guys just want to call it quits, it's up to you. We can keep going or shut it down, whatever you want to do.
You want to get on to the after show open mics there, David? David, you're on mute, my good man. David, you're on mute.
Oh,
Yeah, Neff, let's call it a night now that we've been at the 2-hour mark. I think it looks like we got through the bulk of the best questions, I think, that would pertain to the topic. And
everyone come to my after show or John's after show. We'll be starting in just a few minutes. I gotta brew myself some coffee because I'm gonna need some. Okay.
I said that I was also starting an after show before the debate even began, so I guess I ought to stick to my word and start one.
Well, all three of us are having after shows, so plenty of shows to go to.
Okay, guys.
No shortage to
shows. Right. Thanks for the debate. It's been a heated one a little bit, and it's been a good one. And Standing for Truth and David Neff, appreciate you guys taking a stand for what you believe, and get you guys in an after show.
Awesome. Okay, well, thanks so much, Neff, for doing this. And SWE was saying she was craving a good debate. So I hope this was a good debate, even if these debates get a little heated once in a while. It's the nature of, I guess, the passion of the debaters. So I had a good time, and I hope David did as well. And Neff, thank you so much. Last minute notice for moderating, guys. So it looks like we had 70 people at one point. So God bless everybody. Hope you enjoyed, and SFT is out. See you at the after.